Hello everybody and welcome to my Factoring 101 lesson. So before we jump into factoring any quadratic function, which is probably the reason why you're watching this video in the first place, let's talk about what factoring is, what factors are, and what multiples are. So if we go ahead and take the number 6 over here and we talk about its multiples, and so the multiples of any number is basically if I take my original number and I divide it by my multiple, I should end up with only a whole number. Okay, that is the condition of what makes a number a multiple. I take my original number, I divide it by its multiple, and I end up with a whole number. And so, very quickly, we're going to see that if I take 6 and I divide it by 1, and I end up with 6, that gives me a whole number. This is a multiple of 6. 1 is a multiple. And I'm just going to speed through the rest. If I divide by 2, I end up with a whole number again, so 2 is as well. You're going to find out that 3 and 6 are as well, and those are all the multiples of 6. Now, moving on to the factors of 6, the factors are essentially the two multiples of a number that when multiplied give you the original one. So, since we need to use multiples here, I'm going to go ahead and pop 6 here again. And I'm going to draw a line on the left and put all my multiples down in a vertical line. And I'm going to find which other multiples, when multiplied, are going to give me 6. And the pairs of numbers that come out are each going to be factors. So if I take 6 and if I take 1 and I multiply it by 6, I'm going to get 6. Why did I choose 6? Because it is in my handful of multiples which are legal numbers to use. If I take 2 and I multiply it by 3, that also gives me 6. If I take 3 and multiply it by 2, that also gives me 6. If I take 6 and multiply it by 1, it also gives me 6. And so each of these sets of numbers are going to be factors, right? And so you're nothing more than just separating the number into like two chunks. All right, so keep that in mind, two chunks. And also keep in mind the process. You take the multiples, you put them on one side of the number in a vertical line, you find which other multiples multiply to give you the original one, and then each of those pairs is going to be separate factors, okay? So that is factoring. Now factoring in a quadratic function, I know this is going to sound a little bit confusing, but you have to trust the process here. When factoring in a quadratic function, you multiply a and c, find the factors of that number, which is the product of a and see which factors add up to b. Okay? So, I'm going to read that again. When factoring in a quadratic function, you multiply a and c, find the factors of that number, the product of a and see which factors add up to b. So let's see it in action. Remember that in a quadratic function, we always have the form of f of x being ax squared plus bx plus c. And so in this scenario, we can see that a has to be 1 because there is a 1 times x squared over here. B has to be negative 5 because it's that number right there. And c has to be 6. All right? So now we do a times c, right? A times c is going to give me conveniently 6. And now we find the factors of 6 that add up to negative 5. And so copying what we had earlier, we had 1 times 6, 2 times 3, 3 times 2, and 6 times 1. And so which one of these add up to negative 5? Well, you might already be thinking, hey, but these are all positive values, right? And so how am I going to have a bunch of positive values add up to a negative 1 because I wanted to add up to negative 5? Well, you have to keep in mind that if if my original number is positive, right? Which numbers, when multiplied, give me a positive number? Well, it's either two positives or it's either two negatives. And so you can play around with this a little bit and say, hey, if instead of choosing positive values for my factors, I choose negative ones, I am still fulfilling the role of having a positive number at the end when multiplied. And also I can make them when added together or combined, better said, I end up with a negative value. So if I do, for example, negative 1 times negative 6, I end up with negative 1 times negative 6 is going to give me 6. But if I go ahead and add negative 6 and negative 1, I'm going to end up instead with negative 7. And so, for example, this combination of factors fulfills the role of when multiplied giving you the original, the main number that you need. But when combined, do not give you the b, okay? And so, if we go ahead and dig around a little bit more, we're going to find out that 2 and 3 are the numbers that fulfill this. Negative 2 times negative 3 is going to give you positive 6, so we are all good there. And negative 2 plus negative 3 is going to give me negative 5, and so we're all good there as well. Both of these factors work because they are reflections of each other, so you can do it in whichever order you want. So now we go ahead and take our function and we play around with it a little bit. So we take f of x. We still have x squared on the left side, but we're going to split open the negative 5x. We're going to split it between negative 2x and negative 3x plus 6. So essentially all I've done so far is I take negative 5x and I split it between two terms and I keep going, okay? And so I haven't done anything fancy besides finding the correct factors up until now. What you want to do next is, and perhaps visually this helps you too, you draw a line through the middle, and now you will factor the left side, then factor the right side, and see what happens. Now remember that factoring in a certain way is taking what is common between a set of numbers and pulling it out. What do I mean by this? On the numbers on the left side, we can see that both terms have an x. So what I can do is I take x out, and I have x inside, and then minus 2 inside as well. If I go ahead and distribute over here, we're going to see that I have x times x minus 2 times x. So x times x is just going to be x squared, and I have the minus 2x over here. So all of these sets of numbers that I have put in over here, they are all exactly the same. All we're doing is that we're factoring out, taking out what is in common between them. And so if we do the same on the right side, we end up with the following. I go ahead on the right side and see what is common here, and I see that they are both divisible by 3, so I'm going to go ahead and take out negative 3, and I end up with inside x minus 2. Now, why did I do it this way specifically and not take out 3 without the negative? Well, I want both parentheses to be the same value. Now, you might be saying, hey, that's kind of bullshit, that's kind of magical, like why are both parentheses the same value? Well, it's because I chose my factor very carefully in the steps back here, and if you trust the process, this will always occur. You just need to find the way to factor so that both parentheses end up being the same. This is essential because when we reach this stage, we can factor again. And so if I put a parenthesis on the outside over here and I say, hey, I'm going to factor out the green line here, x minus 2, and I literally take out x minus 2 here, and I see what is multiplied on the inside, we're going to have x minus 3. And so now we have effectively factored the function. Now I'm going to rewrite it down here, and we end up with x minus 2 times x minus 3, and I still have f of x being equal to this. The way to prove that this is effectively correctly factored, which is something that you can do yourself, you can go ahead and distribute here. I end up with x squared minus 3x. Here I end up with minus 2x plus 6. I combine like terms, I end up with my original function. So if you end up with the original function after factoring, that is a good way to check your work that it is correct. But anyway, once we reach this point, honestly, I could end the video here and say, hey, that is how you factor, bada bing, bada boom. But if you're learning this, then that means you have to know the following thing as well. The main reason you do factoring with quadratic functions is because eventually, once you reach this step here, or maybe you do it earlier, what you want to do is take the f of x and equal it to 0. So I have 0 equals x minus 2 times x minus 3. Now, why do we do this? Why do we do this? If I make the whole thing of f of x be equal to 0, remember that f of x is essentially the same as saying y. So what I am doing here is that I am forcing the function to spit out values of x when my y is 0. So in a little bit of a graph here, I am making y0, so that means I'm looking for any point along this horizontal line, which is my x, the horizontal line, um, the x-axis, and effectively I will find the zeros of a quadratic function, because if a quadratic function is something like this, I'm going to end up with the zeros of this number here and this number here, which in this crudely drawn example would maybe be -1, 0, and I don't know, 4, 0, right? Now, if I go ahead and see our original function here, once we reach this step, in order to find the zeros, a lot of people just go ahead and say, hey, my x has to be -2 and my x has to be -3, skipping a whole step and jumping straight from the parentheses to this. This is incorrect. Why is it incorrect? We have to think about this a little bit more deeply. If I have two numbers being multiplied, I'm going to call the first one a and the second one b, that give me 0, that means that either a equals 0 or b equals 0, right? And or both, right? And so if I go ahead and substitute these values, instead of a, I'm going to put x minus 2, and instead of b, I'm going to put x minus 3. And so now I solve individually from this step, and I end up with x equals 2 on the left side and x equals 3 on the right side, which means that my point on the left is going to be 2, 0, and my point on the right is going to be 3, 0, and those will be the two zeros of my function. And so that is my factoring 101 course. Remember, trust the process. That's all that really matters in the end. And I hope it helped. Peace.